Well, welcome back again. We're going to deal with a special case of compound inequalities called double inequalities. Now, double inequalities only mean one thing. They mean and. Just like we dealt with in the last video, they mean and. Only they're mashed up. So basically, they're saying this at the same time. They're saying, I want numbers that when you plug them into the middle, those numbers are bigger than -3 and less than 5. Do you see how they're mashed between there? It says, I want numbers that fit between here and here. That's basically it. Now, that's really hard to just think about what numbers work. That you can plug in, divide by 2, add 1, and make bigger than -3. So -3 is less than these numbers, and 5 is more than those numbers, and those numbers less than 5. So we want numbers, basically, you plug in, you do all this junk, and the result is between -3 and 5. That's what a double inequality does. A double inequality says, hey, what are the solutions that will give you values between these two? Just like every other double inequality. Between what two numbers? Remember the double overlap? Those were between numbers. Even from that negative or 0 to infinity, that was between numbers. Yes, technically infinity is not a number because we don't know exactly what it is, but between two values. That's the idea here. This just does it for you. So you don't have to solve two inequalities. You solve one inequality. A double inequality, basically it's like it's a two for, you get 2 for 1. Now, the big thing is this, that they're not any harder to solve. It's just that there's more involved with them. I guess that does make it a little bit harder if you want to look at it that way, but I'm optimistic here. Here's the big deal with double inequalities. What you do to the center, where your variable will always be in the center for you, what you do to the center, you have to do on both sides. Think of it as a literal double inequality. It's an and that is squished together. That's what's going on. It's an and that's put together. So you're basically solving two at once. What you do here, you've got to do to the right inequality and the left inequality. So let all that stuff, all those techniques of solving work for you. Isolate your variable. Get rid of your constant first after you simplify. Now, why am I saying that? Well, you got a fraction here. You can still deal with your fractions. Now, at this point, you've probably experimented enough with fractions to know that you don't have to get rid of them right away. If you don't really want to, you can work around them. So I'm going to leave it up to you. Me personally, I gave you the advice of always get rid of your fractions. So I'm going to always do that. You don't have to follow my advice, but it's pretty good advice. So simplify this and then get rid of your constant. You'll basically be done. How we get rid of our fractions, if you remember, is you multiply every single term, like all of them, by whatever your LCD is. We would normally change things into fractions. We've moved past that a little bit. So our LCD here is 2. This only fraction we have has a denominator of 2. Multiply every single term, including this one, every term, by 2. The idea is if you're going to multiply both sides of an inequality, now you basically have 3 sides, the middle and 2 wings. You'd have to distribute for stuff that has more than one term. So if you're going to multiply to get rid of a fraction, it's got to be every term. Hey, we multiplied by a positive. We didn't multiply by a negative. With my technique, you never will multiply by a negative. So we don't have to change any inequalities. This is -6, less than or equal to. We multiplied by 2 just so we could get rid of that fraction. Don't forget to multiply that by 2, and we have 10. That's the idea. Notice the similarity between the linear equations that you got rid of fractions and linear inequalities. You still get rid of fractions. You're just multiplying now kind of 3 sides instead of just 2 sides by the LCD. Cross out your fractions and you're free to go. Now, we still want to isolate our variable. It's connected by a constant. Use the same techniques. Let the middle drive the problem. Get rid of your constant by addition and subtraction. But if you're going to have to subtract 2 to get that x by itself, you've also got to do it to both sides. It's a double inequality, meaning you really have 2 inequalities wrapped up in here. You could separate it, I guess, if you want to, but this makes it kind of nice. -6 minus 2. No problem. 2's gone. We're trying to get zeros with addition and subtraction still. X plus 2 minus 2 is x plus 0. That's just x. Now here's the beautiful thing about double inequalities. You don't have to graph them. You see, if you did, it would literally just tell you that. It would tell you that you would have values between -8 and 8. Now that makes things easier. There's one thing I don't want you to screw up though. These always have to be in order from smallest to largest. So if you had your 8 over here and your negative 8 over here, that would be a big problem. We always need these things in order of a number line. This is a number line. It's just written really concisely for you. It tells you the values that work. Hey, the values that work are between negative 8 and 8. You plug in negative 8, you're going to get negative 3. You plug in 8, you're going to get 5. The negative 8 would work for this. The positive 8 would not work exactly for that, but like 7.9999 would. This tells you all the values that satisfy that original double inequality. Because of that, we can basically cheat. And you go, you know what my interval notation is going to look like? This is kind of cool. I don't have to draw a number line. It's telling me the values, any value, x can be any value as long as it satisfies the numbers between these two, the two boundaries here. Hey, when would you use the bracket? Would you use the bracket for the negative 8? Would you use the bracket for the positive 8? Which one would you use it for? We're going to look at our inequalities. Bracket, because that includes the negative 8 as part of the solution set. It says we're including the number that lets this be equal to negative 3. Cool. That lets the equation part of it happen. We're not including the number as this. We don't have that equals. We're not including the number that lets us be equal to the 5 when we plug those numbers in. That's the idea. That's a double inequality at work. The center drives the problem. Use your getting rid of fractions idea if you have to. That's awesome. Just make sure you multiply every single term. All the terms in the middle, all the terms on the sides. And whatever you do to the middle to isolate your variable, which drives your problem, you must also do to both sides. That's the idea. We're going to practice several more of these. Let's look at this one. So we're looking at it. I have no fractions. That's a great thing. I don't have to get rid of any denominators or whatever. I know that this is a double inequality. I see two inequalities, double inequality. The center is always going to contain your variable for you at this level. So let that drive your problem. How would you get your variable by itself? I don't even care what's here. This is driving it. This tells me I've got a constant connected to my variable. Get rid of the 1. Let's get rid of that. By the way, if you haven't realized it, I'm going to tell you right now, never move your variable. Never add or subtract your variable to the other sides. Okay, we want the variable in the middle because this is the numbers that are bound between, or this is the values that's bound between these two numbers. We want that to happen. We don't want to be moving that around. So this stays where it is. That's why I say it drives the problem. It's going to tell you what to get rid of. Get rid of 1 in this case. Remember, if you're connected by addition and subtraction, you're trying to get zeros. Completely eliminate the 1. But we also have 3 sides, basically. If you need to draw a line here and here, I don't typically do that. But if you want to draw a line there and there to say, hey, what I do in the middle, I've got to do to the 2 sides, that's fine as well. Give it a little graphic organizer. Now we keep looking at it. Hey, 5 minus 1, 4. No problem. I get negative x in the middle. Oh, negative x in the middle. Look at that. Because 1 minus 1 is 0. 0 minus x is negative x. We have to remember to keep the sign in front of our terms. That's huge. If we miss that, you're going to see what happens in the next step. If we miss that, this jacks up our entire double inequality. And that's a double, so that's like double wrong. The 2 wrongs don't make it right, all right? So let's not do that. Because we didn't divide by a negative, which is foreshadowing our next step, kind of fun. Because we didn't divide by a negative, you are not going to change your inequality. Now, here's the big part. That right there is not solved for x. I want x by itself. No negatives, no numbers in front. Yes, this does have a number in front. It's negative 1. I want no numbers in front of our x, no coefficients besides 1. Which means, just like any other time you're ever solving, if you let this drive your problem, you need to divide by negative 1 right here. You've got to get x all by itself, isolated with just a coefficient of 1. So, watch carefully. Slow down a little bit. Let's make sure, don't miss this. Let's make sure that we get this. Subtract 1, yeah, get rid of your constant. Do it all 3 places, absolutely double inequality. Get rid of your negative 1, yes. If you just had this, ignore this side. Look at this. You'd still be subtracting 1, yeah. You'd still be dividing by negative 1, yeah. You're just doing it to another side. If we divide by negative 1, this becomes negative 4. We're dividing, not subtracting. This becomes positive x. We're dividing. We're trying to get positive 1s here. Negative divided by negative is a positive 1. 8 divided by negative 1 is negative 8. Now, what happens? What are you going to do? You just divided by a negative. What's that tell you? On any inequality ever, if you divide by a negative, it takes your inequality and it reverses it. Now, you divided both sides by negative, didn't you? Because what you did in the middle, you got to do the sides. So not only does it reverse this inequality, it also reverses this inequality. You're like, yeah, I win. This is D for done. You give this to your teacher as your answer, you're probably going to get it about 60%. At least that's what I would give you, because I'm a mean guy. But you'd probably get about 60%. Because number one, you haven't put it in interval notation. And number two, if you put it in interval notation right now, please watch, don't ignore this. If you go, hey, look, it's all the numbers between -4 and -8. Not inclusive, because I don't have my equal sign. Hey, I got my parentheses right. You did get your parentheses right. But interval notation has to be a picture of a number line, which means you have to go from smallest to largest. What kind of functioned up this problem, kind of effed it up a little bit, was that when we reverse this, when you divide by a negative, check this out. This is an order. 4 is less than 8. It's an order of a number line. But when you divide by a negative, it changes the position on the number line. So kind of like this. 8's to the right of 4, but if I make them negative, the whole thing reverses. And now 8's to the left, -8 is to the left of -4. This is out of order. -4 is more than -8. Well, we have to write it in order. So what's going to happen on your double inequalities is if you have to divide by a negative a little bit later, you're going to take your entire inequality, you're going to take it off the board, and you're going to flip it around. You can write it in the correct order. Inequalities must be written from smallest to largest for double inequalities in order to get our interval notation from smallest to largest. Do not go from -4 to 8. So one more time. Subtract 1, cool. As soon as you divide a double inequality, which originally is in order, that divided by a negative will put this inequality out of order. So we're going to fix it. Take the entire thing off the board, reverse it. So -8 goes here, sure. X goes here, -4 goes here. We've kind of done this idea before, but just with one inequality. Double inequalities is no different. You're reversing everything, which means you're also reversing your inequalities. Now, question for you to think about. Is this inequality, or is it this inequality, this inequality? Think about it before you do the next one. At this point, we're done. All we got to do is translate to interval notation. This tells you the numbers that work. It says, hey, the numbers start at -8 and get bigger and bigger and bigger until you get to -4. That works. That makes sense. Here, this would be like, well, the numbers here, it doesn't make sense to say that. We have to go for in interval notation from smallest to largest non-inclusive. Try that next one before I get to it. Pause the video now, or if you've already done it, awesome. The same technique works, but I want to make sure you understand where these go when you reverse inequality. So focus on that if you're going to do the problem on your own. Right now, we're looking at it, definitely a double inequality. It's definitely an and inequality. All doubles like this, there are two inequalities, are and inequalities, which means I'm looking for numbers that when I plug them in here are between 3 and -9. It could work for -9, or -9. It could work for 9, but not work for 3 exactly. So we're looking for and, these numbers that are matched between 3 and 9, not including 3. The middle is always going to drive your problem. It's the same stuff, guys. Only do it to all 3 sides. If you're going to subtract 5 to get rid of your constant, what you got to do, subtract from the left, subtract from the middle. You better darn well be sure that you can keep that negative. Subtract 5, you're going to get 0. 0 minus -2 is -2x. Keep the sign in front of the term. Because we didn't divide by a negative, we don't have to change any inequalities until now. If your center is going to drive your problem and you're going to have to divide by -2, that's totally fine. Just remember, if you've got to divide by -2 to get rid of your coefficient, trying to make 1s here, but with division multiplication, trying to make 1s. Divide by -2 so that this becomes -2 divided by -2, that's +1. 1 times x is x, that's cool. I gotta hit all 3 sides, that's +1, this is -2. Do you see that when I divide by a negative, it changes the sign of a number? That means that large positives, if you divide by -1, become really, really small negatives. I mean, further to the left. That's the idea. Small positives become small negatives. Small negatives become small positives. Vice versa with the large numbers. Really large positive become really small, really negative numbers. That's the idea here. So if I'm going to divide by a negative, my inequalities, oh look, divided both sides. This changes. This one also reverses. So subtract 5, cool. Divide by -2. Oh, you divide by negative. Change both inequalities. But then look, you're going to go to interval notation. Right now, you cannot write that the way this is in order. It's not in order. We have to have our intervals in order from smallest to largest. When you divide by a negative, it's going to reverse your inequalities, and it's going to change the signs of your numbers. It's going to put stuff out of order. Take this off the board and reverse it, which means your -2 is smaller than 1. Yeah, right on the left. Your x is in the middle and your 1's on the right now, but follow your inequalities as well. The relationship between x and -2 has an equals associated. Make sure that follows with it. The relationship between x and 1 does not have an equals. Make sure that follows with it. So we took this off the board, we reversed it, we put it back. So now -2 is less than or equal to x, which is less than 1. Basically it's telling you, hey, all the numbers that are in your solution set are going to be between -2, including the -2, and 1, but not including the 1, like 0.99999 for a really long time. That's the idea. I'm going to show you one more with fractions. You probably have enough to get going on this. What I would really recommend, because right now these 3 examples should have taught you the idea of double inequalities. I'm going to put the example on the board. I really recommend you stop and try it. It has some fractions involved, so this is the more complicated example. It has the reverse idea. It's got the flipping inequalities. So try that. Here it is. So let's do that. -3/2 is less than or equal to 4 minus 2a, which is less than 7/2. Try that on your own as I'm erasing the board, or if you want to pause the video, give it a whirl. Okay, if you've already worked it out, great. If not, you'll work through it with me. I'm going to ask you questions about it. What's the first thing you're doing here? With any equation or inequality ever, the first thing we should be doing is you got to simplify some fractions. You got to get rid of your fractions. Otherwise, you can do it. You totally can do it. But it's just so much easier to get rid of fractions. If you're going to, though, if you're going to get rid of fractions, you find your LCD, which only includes your denominators. Normally, I'd make you write this over 1 so that you can find your LCD very easily. Your LCD should be 2. That's the smallest number that all your denominators divide. These are not included in denominators because they're on the numerator of a fraction when you write it over 1. So we're going to multiply everything, all 3 sides, every single term based on distribution by the LCD of 2. So that means I'm probably going to associate my negative up here. I always associate negatives with numerators. That way we don't have to worry about them on denominators. We'd multiply by 2 and 2. But don't forget this basically, for all intents and purposes, has 3 sides. That third side in here, wow, sorry I did it in my head, has 2 terms. So if you're going to multiply that side, it's going to distribute. So let's make sure. LCD was 2, I multiply by 2, by 2, by 2, and by 2. Everything gets multiplied by 2. Remember that we're trying to get rid of fractions here. So we multiply by 2 to kill our fractions. We're only left with -3. In here we had no fractions. It just had to play along. It had to get multiplied by that 2 to keep this relationship between our inequalities consistent here, to keep it well, not equal, but to keep the relationship the same. Here we have 8. Here we have -4a. Nothing cancels, nothing simplifies. We just had to multiply every term by the same number. Here we kill the fraction, we get 7. Because we didn't multiply by a negative, you do not flip that inequality. So, got rid of the fraction, -3. Didn't get rid of the fraction, we have 8 and 4a, no problem. Got rid of the fraction, we get 7, inequalities stay the same. Now you're home free. We should be getting rid of our constant. We can do that. -11, not changing my inequality. Less than -1, not changing my inequality. Look how it's still in order. Look how I have to have negative 4a. Gotta have that negative. Checking my work here, looks pretty good. Now our last step. What's your last step? What's your last step all the time with like solving equations, inequalities? What's the last thing you do? Heck, you're always dividing. Here, when you divide, we're trying to get positive ones. In order to get positive ones, you have to divide by whatever number is in front of your a. In this case, you have to divide by negative 4. When you divide by negative 4, a negative divided by negative becomes a positive. It changes the sign of whatever numbers you're working with. So negative 1 divided by negative 4 is positive 1/4. Who cares if you have fractions? You're not even really working with them. They're just going to be there. That's okay. Negative 4 divided by negative 4 is positive 1. We're trying to get ones. 1 times a is a, but because you divided by a negative, I even got positive numbers. I don't care about that. Because I divided by a negative, the inequalities have to reverse. Now, is this good enough? Are you going to get full credit if you give me this? If you give your teacher this? Is that good? Well, it's great, but it's not finished. So yeah, it's good, but not good enough to get full credit on it. This is written out of order. Take this off the board. 11/4 is larger than 1/4. Take it off the board and reverse it. That way you can write your interval notation accurately. If we reverse this, the inequalities that are associated with their numbers have to follow those numbers. So basically what this says is that all numbers that are going to work in this double inequality, they're going to be in the solution set, are the numbers between 1/4 and 11/4, not including the 1/4. It says it right here. But yes, including 11/4. It says it right there. It just follows that around when you reverse it. Do your interval notation, which comes directly from this, is kind of nice. It says I'm just looking for the numbers between 1/4 and 11/4. That's the idea of compound inequalities when they relate to and. So we talked about and last time, we talked about and this time, only this particular compound inequality is called a double inequality because you do the same work on both inequalities at the same time. It's put together, you get two of them at once. That's the double idea. So I'm hoping that makes sense to you. Right now we basically beat to death the word and. We know what and means, works in both. We have it a variety of ways, now we have it in double inequalities. So make sure you're doing the same thing to all three sides, if you will, and if you divide by negative, you're ultimately going to flip both inequalities and then reverse them back. Make sure they're in order before you write your interval. So we'll talk about or in the next video, and then that wraps up our inequalities.